Welcome to day one of Discrete Math, Intro to Discrete Math and Graph Theory. Now you are probably wondering, what is discrete math? It is a study of mathematical structures that are discrete, not continuous, things that don't vary smoothly. Now let's take a look at graphs. Here are some examples of graphs of discrete and continuous. If you notice, the discrete graphs, they are not joined together, and continuous, they're connected and they keep on going. Now, there's some topics that we talk about in discrete math, such as roots and schedules, the best way to schedule different things happening, election, fair division, and also we do some many things that you do in management science, business, technology, and life in general. Now, what do you guys think? Can you walk every hall on the main floor without walking any hall more than once? I'm going to tell you, no, you cannot, because you might have to go down one hallway and then back again to travel to the other ones, like the PE hallway. Now, in Chapter 5, we're going to see that graphs are not just X and Y anymore. They can actually show relationships. Now, we're going to investigate how to determine the most effective route for the delivery of goods and services. Now, it could apply to mail and package delivery, garbage collection, and police patrols. So we're going to be dealing with graphs that are not like the ones in algebra. Now, of course, it has to come with new sets of definitions. Now, a graph is a picture consisting of edges and vertices. Basically, we're talking about dots and lines. Vertices are the dots, edges are the lines, and that's how the dots are connected to each other. Now, we also have something called adjacent vertices, adjacent edges. Adjacent just basically means that they are next to each other. Vertices are adjacent if there's an edge joining them. Adjacent edges are adjacent if they share a common vertex. Now we also have something called a loop. A loop is an edge that connects a vertex with itself. So here is a vertex. Okay, it's just a dot, and I'm going to show a loop. It starts and then it goes back to it. That right there is a loop. Now we also can talk about the degree of a vertex, and that represents the number of edges at that vertex. Now if you notice, we show degree as DEG and then A. A is the name of the vertex. So what you can do is have a dot at A, and then you would have two lines coming out of that. So that is the degree of a vertex, just the number of lines that come out of it. Now we also have something called a path. It's a sequence of edges that each vertex in the sequence is adjacent to the next one, or basically that means next to. Now we also are going to talk about the length of a path. It's the number of edges. So it's also a circuit we talk about too. It has to start and end at the same vertex. It is very similar to a path, except a path starts at one place, ends at a different one, and a circuit, you start and end at the same place. Now we also have something called connected graphs and disconnected. Connected is when all the vertices are joined together, and there's a way to go to each one of them. Disconnected means that they're not connected. Now, so here are some other definitions too as well. There are different types of graphs. Now, when you have separate disconnected vertices, they are called components. When a graph has more than one edge connecting the same pair of vertices, it is said to have multiple edges. Now, disconnected graphs can consist of two separate components. When we talk about vertices and edges, with vertices we just use capital letters, and edges we use two letters. Now let's take a look at the example. Now if you notice, I have dots and they have names on it. So the dots that we're going to say are A, oopsie, let's see if I can make that bigger, A, comma, B, comma, C, comma, D, comma, E, and F. So those are the vertices, and basically all you're doing is writing down the dots. Okay? Now, what we want to do is figure out what the degree of each vertex is. So the way that we show it is D, E, G, oopsie. There we go, D, E, G. And then it's going to be A. So we put that inside parentheses. You put the name of the vertex inside parentheses. Now we're going to count to see how many lines come out of A. So here's A, so we count the number of edges, so that's 1, 2. So there are 2 edges coming out of it, so that's why the degree of A is 2. Now what we're going to do is find out the degree of B. Now if you notice, at B, this right here is called a loop, okay? Because it starts and it connects back to itself. Now when you have a loop, the degree is 2. So the degree of B is actually 1, 2, 3, 4, 5. So you have to remember that if you have a loop, the degree would be 2. Now degree of C. Okay, let's see. It has 1, 2, 3 lines. So that's why it's degree of 3. Degree of D is 1, 2, 3, 4, because there's 4 lines coming out of it. Degree of E is 2. Now, if you notice, we do have F. F is a vertex that's not connected to everything else. We can say that this is a disconnected graph. So the vertex F has a degree of 0 because there's no lines coming out of it. Okay? So that is how we are going to notate degree. Now what we're going to do is talk about the edges. For the edges, I'm going to type it underneath here so we can see where his edge is. Okay, basically all you're doing is listing the lines. So you have to make sure you use 2 letters though. My very first edge we can do is AB. From here to here, AB. Okay, so we did that one. And now the next one that I'm going to write down is, let's see, CD. Okay. Now my next edge that I'm going to write is, let's see, let's take a look at the graph. Okay, so CD, if you notice, bell. That's okay. So here's one CD, and if you notice, I have another one right there too. So CD is actually going to be written down twice. That right there represents a multiple edge. Now we have more edges. How about BC, DE, BE, AD. Alright, let's see, what other edges do we have? So I did AB, CD twice, because that's a multiple edge. And I have BC, DE, BE, AD. Now, if you notice, I have a loop. That's a loop right there, because it starts and ends at the same place. So the way that we show loops is I'm just going to write down BB. So again, edges are the lines. Now my loop we said was at BB. So that is all we have to do for that part, okay? So now we know how to identify the vertices, give the degree, the edges, and loops. Again, edges, you need 2 letters. Degrees, you just count the number of lines that come out of each dot. Now, if you take a look at number 2, it says, is this a graph? And I'm going to tell you guys, yes, it is. it's a graph. Even though it doesn't have any edges, it still has vertices, and that's okay. Now we're going to learn later on that a graph just shows relationships. This basically just shows that there's no relationship between any of those dots. So now our vertices are going to be just the letters, so it's A, B, C, and D. So those are my vertices. And now edges, I don't have any edges because there's no lines at all connecting. So we're just going to write down none. All right. Now what we're going to do next is we're going to reverse it. I'm going to give you the information and you draw the graph. So now it doesn't really matter where you put the dots. So I'm going to put my dots A. All right, so we're going to say this is A. We're going to say that this is D. Really bad D. Here's your L. And we're going to make that R. Okay. So now all we're going to do is connect my dots. So A to R, so we're going to do a line. Okay. Now if you notice, AR is there twice. That's a multiple edge. So we kind of curve it. It doesn't necessarily have to be curved, but since there's two of them, you want to be able to see them. Now I'm going to connect between AD, then I'm going to connect A to L, and actually A to L has a multiple edge, then DR, then DL. Okay? Now it's very important to remember that the shape does not matter. What matters is how the vertices are connected to each other. Okay? Now, if you notice, we have another example, okay? So we can definitely look through that, go for it. All right, there's many different examples of it that you can do. So hopefully you take a second and try it. All right, now that we have explored graphs a little bit, here's a definition. It's a structure for describing relationships within a set of objects, the vertices. It's a story of how things are related. Now here is a dating game example. Below are 8 teenagers. What can we learn from this graph about their dating habits? There's a lot of stuff that we can learn. If you notice, Veronica and Archie are by themselves. They only date each other. But then also Meg can date Moose, and also that's it. Alright, sorry for all the interruptions. So there's a lot of stuff that we can tell with this, okay? There's a lot of interpretations. It shows relationships. Now, you could also say that maybe Betty, shakes hands with Reggie, and Betty knows Moose, Betty knows Jughead. But if you notice, there's no line connecting Betty and Ginger, so we can say that they don't know each other. So there's a lot of stuff that we can tell.